All right, so here we are going to give a shot at some more inverse function derivatives. We have some problems we're going to take a look at on the sheet that you have, and we're going to just work through them, and we'll talk about the idea of finding these things at buddy points and see if we can find these derivatives. So vocabulary once again, chain rule, inverse function, and buddy point. And let's jump in. So this is kind of a discovery learning way of finding out about these derivatives again, and it's definitely a good thing to do. The inverse derivatives often are forgotten by calculus students, so don't let it happen to you. So let's give this a shot. So we're going to use calculus here to write the equation for the tangent line to this function at x equals 1, and we'll draw it on the graph. So at x equals 1, that's going to correspond to right up here. So we use calculus to do this. So we have a point and a slope. Our point is going to be 1, and then f of 1. So 1 minus 1 is 0, plus 3 is 3. And our slope, we're going to have to find f prime of x. So f prime of x is going to be 5x to the 4th minus 3x squared plus 3. So if we evaluate that at x equals 1, I'm not going to write that because we're going to use that again later. We have 5 minus 3 is 2, plus 3 is 5. So our equation for our line is going to be y minus 3 equals 5 times x minus 1. I'd buy that because that's a pretty steep slope right there. So we're going to draw that in our graph. There's our tangent line. Now, what they want us to do is got to the inverse of f. Okay, so that's going to be reflected over the line y equals x. So let's see if we can find some points. 1, 3 is going to be translated to 3, 1. That's a buddy point right there. Negative 1, negative 3 will be translated to negative 3, negative 1, excuse me. And then it just kind of does a lane change through there. So something kind of like this. There we go. Okay. And now what they want us to do is to plot the point on G that corresponds to 1 f of 1. So 1, 3 turns into a buddy point over here at 3, 1. Now what they want us to do is to approximate the slope of the tangent line at that point. Well, if we draw in that tangent line, something like that. And they want us to approximate the slope. Well, if we want to do rise over run, it looks like it's positive for sure. Looks like it goes to this point. So we rise 1 and run 1, 2, 3, 4, 5. So maybe about 1/5. Interesting. Slope up here is 5. This is 1/5. Maybe there's a relationship there. So, oh, sorry, that was down here. And now they want us to make a hypothesis. It looks like at buddy points, a function and its inverse, so inverse functions have reciprocal slope. Inverse functions have reciprocal slope. Recip slope. Cool. All right, let's see what else they got for us. So here we have sine x, and we're on the interval negative pi over 2 to pi over 2. So first I want us to write an equation for the tangent line at pi over 4. Pi over 4 is like 3/4, so it's like somewhere around here. Okay, so we need a point and a slope. So our point will be pi over 4, and then sine of pi over 4, which is root 2 over 2. And our slope, well, that's going to be cosine of pi over 4, which is also root 2 over 2. So our equation is going to be y minus root 2 over 2 is equal to root 2 over 2 times x minus pi over 4. There we go. All right, now they want us to sketch the inverse. And the inverse is going to be this thing reflected over the line y equals x. There it is. So it's going to start at, let's see, our y coordinate here is going to be whatever the x is here, which is pi over 2. Our x coordinate is going to be negative 1. So that'll be like down here, right, reflected over the line. And then it looks like it'll bump up here across the line just a little bit, cross through, and then end up, let's see here, it's going to have a x coordinate of 1 and a y coordinate of pi over 2, so about there. So it's going to look something like this. All right, let me get rid of my dotted line here. Okay, so the red right there, it looks a lot like the sine function, but it's kind of turned on its side, right? It's been reflected over that line y equals x. Now they want the point that corresponds to pi over 4 f of pi over 4. So that was pi over 4 root 2 over 2. That was right about there. So now we're going to be at root 2 over 2 pi over 4. So that's going to put us right about there. Pretty darn close to the other point, because if you reflect it over the line y equals x, most of the sine graph is close to that line. So now they want us to use calculus to find the slope of the tangent to g. So g is sine inverse x. So we're going to do sine inverse of root 2 over 2, which is pi over 4. So our point now is root 2 over 2 pi over 4. Notice that the coordinates just switched from what they were up here. And our slope is going to be 1 over the square root 1 minus x squared. So 1 minus root 2 over 2 squared. So that's going to be 1 over the square root of 1 minus root 2 over 2 squared is 2/4, which is 1/2. So this is 1 over the square root of 1 minus 1/2 is 1/2. So that is what? Root 2 altogether. So that's 1 over root 2 over 2. Nope, I don't want to write it that way. So this would be 1 over root 2. So the reciprocal is root 2. Okay. And the question is that the reciprocal of this guy? Well, that would be 2 over root 2. If we rationalize, root 2 on top, root 2 on the bottom. This is 2 on the bottom. The 2 will cancel with that, so we have 2 root 2 over 2. Those cancel. So it is root 2. Yep, so yes, matches our hypothesis. That's pretty cool. So let's see what they have for specifics here. So for inverse functions f and g, if AB is on f, then BA is going to be on g. The slope of f at AB is f prime of a, right? That's just the definition of derivative. And the slope of g at BA is going to be g prime of b. So we have some kind of relationship here. So if f prime of a is equal to, let's call it m, that's our slope, then g prime of b is 1 over m. So it's important here that these are buddy points, right? So g is looking at point b for their x-coordinate. F looks at point a. Oh. So now we're going to do some algebra problems here. So there's a point on f in which the y-coordinate is 9. What is the x-coordinate at that point? They want us to guess and check. So there's something that has 9 equal to x cubed plus 3x minus 5. Well, if they tell us we can guess and check, hopefully it's not too complicated. Let's try 1 first. 1 cubed is 1, plus 3 is 4, minus 5. Nope, negative 1. That won't work. Let's try 2. 2 cubed is 8. 8 plus 6 is 14. Minus 5 is 9. So the x-coordinate is going to be 2. So write the point as a function notation. So f of 2 is 9. I'm going to write that as 2, 9 as an ordered pair as well. So I want to know what point on f inverse corresponds to the point that we found. That means that 9, 2 is the buddy point for that one. So in function notation, f inverse of 9 is 2. So you plug 2 into the function, it scrambles it up, makes it 9. Then 9 is cleaned up again by the inverse function to make it 2. Now they want us to find f inverse prime of 9. So they want us to find the derivative of 9. So we're going to do our little chart here. So we know that 2, 9 is on f, and 9, 2 is on f inverse. Now we have to find the slope. So I think we can find the slope of f, right? F prime of x would be 3x squared plus 3. So the slope there, so f prime of 2, if we plug 2 in here, 4 times 3 is 12, plus 3 is 15. So then f inverse prime of 9 is going to be the reciprocal of that, right? Because these are buddy points. So that's going to be 1/15. Nice. All right, let's try another one. So we're given a function here, and they tell us f of 1 equals 12. So that tells me 1/12 is on f. So what's on the inverse? Probably getting the hang of this by now. 12/1 is on f inverse. Okay, now we got to find some slopes. They want to know the derivative of the inverse function at 12. Well, that's the one I want because that's the x-coordinate on the inverse. But first, let's find the derivative of f. So f prime of x is going to be 7x to the 6th plus 2. We're going to evaluate that at x equals 1. So the slope of the f function itself, when x equals 1, is going to be 7 plus 2, which is 9. So that means the slope at the buddy point is what? 1/9. Very cool. All right, next up, so this is kind of the bare bones. So we have the x-coordinate of f inverse. So I don't know what point is on f. And I don't know exactly the whole point that's on f inverse, but we can figure it out. So 13 is the x-coordinate of f inverse. That must mean it's the y-coordinate of f. So I can solve that. So we have 13 equal to x to the 5th plus 3x plus 7 plus 2. So I don't know the x, so we have to kind of guess and check again. Let's try 1. 1 plus 3 is 4, plus 7 is 11. Plus 2 is 13. So we have 1/13 on f, so then 13, 1 is on f inverse. Now we have to find the slope of f. I can't find the slope of f inverse because I don't have a function for it, but I can find the slope of f because I've got it right here. So f prime of x is going to be 5x to the fourth plus 3. Oh, it's just x. Interesting. Plus 7. All right, so that's 10 plus 5 is 15. So slope at 1 for f is 15. And the slope for the inverse at its buddy point is going to be 1/15. Not too bad at all. All right, that's all I've got for you here. Love you guys. Go ahead. I'll see you in the next video.